Hello everyone. We're going to learn something interesting known as logarithms. So one may ask me why we should study logarithms. I say we should study logarithms because they have multiple uses in practical fields in the real world. For example, in chemistry, the pH of any acid or base is expressed in terms of logarithms. In physics, we have them for making the graph of radioactive decay. For predicting earthquakes, they're also used widely. So, going away from this to our topic, before starting with logarithms, let's know something about exponents. So, recall Ben from the show Ben 10. Here we'll write Ben as b power e is equal to n, where b is equal to base, e refers to exponent, and n refers to the number. So if you want to express 16 in this form, let's try how we can do that. So for example, if 16 is equal to 2 into 2 into 2 into 2, so that's 2 into 2, 4 into 2, 8 into 2, 16. That's 2 4 times. So if you want to represent it, it would be something like is equal to 2 power 4. Here 16 is the number, 4 is the exponent, and 2 is the base. Well, logarithms take this one step forward and express the same exponential equation in the logarithmic form. So if you want to write the Ben in the form of log, how can we do that? It should be log base b, exponent goes to the solution of the equation and the number goes to top of the log. That's in the same line. So we say this as log base b of number is equal to exponent. So let's see how we can convert this equation into the logarithmic form. So here log of what's base? Base, it's 2. What's the number? It's 16. And what do we get? The solution 4. So it's log base 2 of 16 equals 4. So log basically helps us find by how many times do we need to multiply the same number to get the number. That is, to what power should we raise the base to get the number, right? So log is a kind of function that takes in values and gives the exponent. So let's try an example. If we have log base 3 of 81 is equal to x. So sorry about that, it should be in the same line. I'm going to explain a topic using this, so that's the reason I wrote it here. So let's count together how many times do we need to raise 3 to get 81. So 3 into 3, let's try. 3 into 3, that's 20. That's 3 into 3, 9 into 3, 27 into 3, that's 81. So the answer to this should be 4. Well, we can express, let's try converting this into exponential form. How can we do that? So taking the same concept of Ben, we can try doing that. So for converting this thing into the exponential form, what we can do is use the concept of Ben. So according to Ben, what's the base? Base is 3 here. So let's put that here. What's the number? Number, it's 81. So that should go to this side. And what's the exponent? It should get raised to this number. So let's put that here 4. So 3 power 4 is equal to 81. Let's try one more example. Log base 2 of 1 by 16 is equal to x. We need to find to what value should 2 be raised to get 1 by 16. So using the properties of exponent, let's try converting 1 by 16 in the form of 2. So 1 by 16 is equal to 1 by 2 power 4. That's 2 into 2, 4 into 2, 8 into 2, 16 is equal to 2 power negative 4. So answer this equation should be negative 4. Well, we can do this every time, and whenever we want to convert to the exponential form, we can actually try doing that right now. It should be 2. What should be the power? Minus 4 is equal to 1 by 16. But there's a simpler way of doing that, and it's actually much quicker. So let's try how the simple method works. So this will be our logarithmic form. And let's write our exponential form here. Base power exponent is equal to number. This will be our exponential form. So what we need to visualize is, let's think of n as being heavier than b and pushing b down, actually trying to push it to the other side. So if n goes down, b has to go to the other side, and b goes this side, right? Alright, and then b pushes e up. So that's the same thing here. N goes down, pushes b to this side, and raises this. B exponent power e is equal to n. It's the same thing both ways. If we need to revert back to the logarithmic form, what we can do is push n, like e pushes b down, so right, it should go down, b gets pushed to the other side and raises n. So that's the same thing. Let's try writing it. E goes down, e equals b goes to that side and makes logarithmic form. So n goes up, n, and what's the base? B. That's the same thing we got here. This is actually easier, and when you get into the way of doing it, it turns out to be much simpler. So let's try using one example of how this works. So we have log of base 2 of 1 by 128 is equal to y. So to what value should 2 be raised to get 1 by 128? Using a simpler form of pushing stuff down, let's try that. 1 by 128 goes down, pushes 2 to the other side, and raises y. So it turns out to be 1 by 128 is alone, it goes down, is equals to y raises up, 2 goes to the other side, 2 power y. That's it. We just need to convert 128. So 1 by 128 is equal to 1 by 2 power, let's try using this form. 2 into 2, 4 into 2, 8 into 2, 16 into 2, 32 into 2, 64 into 2, 128. That's equal to 7. Let's put 7 here, and when we convert it, it will be 2 power minus 7. That's it. 2 power minus 7 is equal to 2 power y. Since the bases are same, we can equate y is equal to minus 7, and that's our answer. Well, that's it about how you can easily use this method instead of other complicated methods to easily convert logarithmic forms to exponential forms and vice versa, and easily solve your solutions. So before we stop this video, let's try one more question. Log base 10 of 1 is equal to what? So it's always equal to 0, because any number raised to 0 always gives 1. So if it had been, let's say, z, then 1, this goes this side and pushes this up. So 1 is equal to 10 power z. So if we put z as equal to 0, then we get 10 power 0 is equal to 1. That's it. Thank you for watching. In the next video, we'll be learning about logarithmic properties.